so we're going to want to have two things handy for this lesson. One is a PDF that you should have by now that I didn't send yet, because I'll send my emails after I'm done filming videos here. But I'll send you a PDF of this that I would have handed you in person. It's titled Quiz Algebra 2 5.7. And it starts off with a big empty space at the top and then a lot of factoring problems at the bottom. And we're going to start off by filling in the big empty space at the top. So if you don't have that, you might want to pause the video, find that, and come back. The other thing you're going to probably want to locate is the chart that's still on the board from the previous lesson of the numbers, the squares, the cubes, because we're probably going to use that a decent bit, or at least refer to it. So if you have that handy, that's probably going to help you. Okay, but we're going to fill in the top of this just using information that is on page 132. So if you have a book, you can look at page 132. If you don't have a book, I'll just talk you through the 1 to 8. The box at the top of page 132 basically gives you a strategy of how to factor. We're going to be taking quizzes like this in upcoming days a bunch of times. I'll generally take these until the group as a whole can average 90% on it, which we've always managed to achieve in the past, but it takes work. We'll end up doing it, for sure minimum 4 times. If we were done after 4 of these, I'd be pretty surprised. I'd say an average year is more like 6-ish attempts as a group, but I've had years it took maybe 8-ish times before we can as a group get this figured out. On a 17-point quiz at 90% is 15.3. So if you're going to get above a 15.3, you help the group a little bit. If you're below a 15.3, you're hurting the group either a little bit or a lot. Usually we start off with some people, the first quiz will get like a 2. So there's no way we're going to overcome a 2. But if we can get our worst scores up to like 12s and 14s or something like that, and our better scores end up being 17s, a bunch of 17s out of 17, we eventually can average it out to be a 90, but it takes some time. So your best strategy as a student for your grade is study this for attempt 1, which will be next time I see you, whenever that is in person, and then we'll see how it goes. If you start off out of the gate with good scores and good scores and good scores, then we're gold. But you don't want to be that person that gets a 2 and then a 2 and then a 2 and then a 2 and then an 8 and then a 10, and then your 10 finally lets us get above the 90 and you're decent at it, and we're done. So you got a bunch of like bad scores and it stops. Well, here's our strategy. The top 8, you just have to memorize it. If you memorize the top 8, you're helping yourself. If you don't memorize the top 8, I really can't help you. You've got to just put in the time and memorize these top 8. So the top 8 is going to have 3 main steps, but with some sub-steps. Okay, so step 1 on this, first thing you always want to do is take out a GCF. So number 1 on this paper, you should write number 1, take out a GCF. You can't always do that, but anytime you can take out a GCF, you want to take out a GCF from the whole problem, meaning greatest common factor, something that's on all the pieces. Step 2 is to consider the number of terms. You get 1 point for that. Step 2, you consider the number of terms. Depending on how many terms there are, now we're going to get some sub-steps, and we'll talk this through some examples that we'll do through our day. But step 2 is count the number of terms, consider the number of terms, something like that. So call that step 2. Step 2A, let's say, is if there's 2 terms, there's 2 possible points worth of things that you need to be ready to say. If you have 2 terms, your problem is either going to be a difference of squares or it's going to be a cubed problem. So 2 terms, you get 1 point for saying it might be a cube problem. You get 1 point saying it might be a difference of squares problem. So that's like 2A. 2B, if you have 3 terms, I'm going to say just unfoil it. A 3-term problem is like the ones that we've been doing for more than a week, I'd say. I'll call it unfoiling, where we look at the signs and we multiply to this and add or subtract to that. 3 terms is what you're most used to doing. So that'd be like step 2B. Step 2C would be if there's 4 or more terms, we have 2 options. 4 or more terms, either try to combine like terms, to make the problem smaller. Or factor by grouping is our other choice. So step 2C, if there's 4 or more terms, then 2 points worth of stuff, either combine like terms or factor by grouping. And then step 3 is factor completely. Meaning sometimes you factor and then you need to factor again. Just like reducing fractions. If I gave you 120 over 144, you'd probably have to reduce and then reduce some more and then reduce some more, and it would take you a while to get that down to 5/6. But here's the steps once again in case you missed it, and if you really missed it, it's in the book on page 232. So I've just narrowed down what I'm saying a little bit shorter than what the box in the book has said. So I'm saying step 1 is always take out a GCF. That's 1 point. Step 2 was count the number of terms. And then there were sub points there. I'll double back to the sub points. Step 3 is make sure you factor completely, meaning sometimes you factor and then refactor. So that's our 3 main steps. Okay, 1, take out a GCF. 2, count the terms. 3, factor completely. In the count the number of terms, we had a lot of points in there and sub points. So like sub point A would be 2 terms. There's 2 points. Either it's a difference of squares or it's a cube problem. 3 terms is only worth 1 point, you unfoil it. 4 or more terms, and I want you to say 4 or more, don't just say 4, say 4 or more, 4, 5, 6, 7, anything more than 4 or more. 4 or more terms had 2 points, which is to either combine like terms, which should shrink the problem down, or to factor by grouping is a skill that we've already done a couple lessons ago. And the book has, I believe, all of that in there. I'll do a quick skim. So again, take out a GCF is in there. They say it a little differently than I do, but it's certainly there. Step 1, take out a GCF. Step 2, count the number of terms. 2A, if there's 2 terms, it's a difference of squares or it's a cube problem. 3 terms, I'm just saying unfoil it, which is much shorter than what they say in the book in this box. Just you say unfoil when you're good. 4 or more terms, we're going to either combine like terms or we're going to factor by grouping, which is similar to what they say in the book, but mine is said much shorter. And then the last step was factoring complete. If you didn't catch that, that's why they have rewind buttons, so you can just watch and fill that in. But make yourself a study paper there on the first 8. There's 8 total points because there was 3 main points. The 2-term thing had 2 points. 3 terms had a point. 4 or more terms had 2 more points. That's the topic. Let me do the examples on the board, and then we'll come back to this. So example problems on the board. First thing I'm going to do is try to take out a GCF. So I'm just following the steps that we just wrote down. GCF for this, 10 goes into both things, and X is on both things. So I'm going to take out a 10, I'm going to take off the X. If I do that from the first term, I'm only left with a squared, a minus. 40 dividing 10 is 4, and I'm left with a b squared. So that's step 1, factor a GCF. I need to make sure I factor completely, and this is not factored completely. I'm going to focus my attention here and try to refactor that, and it's going to factor. What I would do to decide how is to look to see how many terms there are. This is 2 terms. So that either has to be a cube problem, which we did yesterday. This is not a cube problem from yesterday, because these are not divisible by 3. And if we're looking at our table, 4 is not in the cube part of that table. That's not what this is. So this has to be either a difference of squares or be done. And I just said it isn't done, so it must be a difference of squares. How you know a difference of squares when you see it? There's 2 terms. Has to be subtract. That's what the word difference has always meant. So we're in the running for that. And to be squares, we need powers to divide by 2, and we need a number that's in the squares column of our chart. And I'm not going to stroll left and look at the chart. You have your chart. The 4 is in the squares column of that chart. So this is a difference of squares. Difference again means subtract. Square column can divide by 2. That's what a difference of squares is all about. So we do the power divided by 2, mirror it on both. 4, we square root it to get 2's. Oh, maybe I'm going to take a stroll left of the chart. We're just taking the 4 in the squares world and taking a step back to turn the 4 into a 2. That's how that's working for square roots. The b power will divide by 2, so a pair of b's. And then we're going to go 1 plus and 1 minus, always different signs when we have differences of squares. And then we think, are we done, or can we factor some more? We can't factor more because we ran out of powers. If you run out of powers, then you're just done factoring. But if these were like powers still here that could divide by 2's, maybe we'd have to do that again. If these were powers somehow that could divide by 3's, maybe we'd have to divide again. But they aren't. This is just, that's not. Next one up. Always think, do I have a GCF? Sometimes, as it is here, the answer is no. You don't always have a GCF. Sometimes you do, sometimes you don't. So if you don't have a GCF, move on. Count the number of terms. 2 terms. 2 terms has 2 choices. Difference of squares have powers we can divide by 2, and they subtract, and that is the difference of squares. Cube problems have powers that divide by 3. So that is also a cube problem. It's actually both. You could actually do either thing with that. I'll tell you, it's going to be easier if you can do them both to do the difference of squares system function. So I'm going to go and do the same thing I did a second ago. It's a difference of squares because it's subtracting, and the powers can be divided by 2. So I'm going to divide the powers by 2. So the x has some 3's. The y, divide the power by 2. So the y's have some 3's. And the differences of squares will always go with signs that are different. So mission 1 accomplished. Then we always have to think, did this get factored completely? Or if this were standing alone, is that a problem we could do? That standing alone is a problem we can do. We did them yesterday. We did 21 of them yesterday for homework. We did a bunch on the board yesterday in the class video. That's a cube problem. We know it's a cube problem because the powers can divide by 3. So we're going to ignore what's under my arm, but I can't really keep that under my arm forever. But what's under my arm, we just have to ignore it for a second and focus just on this problem and do yesterday's skills today. So yesterday's skill was, the first item, divide power by 3. Copy sign. Second item, divide power by 3. Wrap that up. And then we quit looking at the original problem and we look only at the factor we made to make another factor. By doing the x times itself is x squared. The y times itself is y squared. Our sign needs to be different. And then we multiply them together to get an xy. Now I'll cover this back up with my arm. What we did is traded this first thing for those 2. That doesn't mean we're done, that means we're better. What we still need to consider is the thing that's under my arm, is that a thing we could also factor? So then in your mind, you have to blot this out because it's gone and been handled and been traded for this. We don't worry about it anymore. We look at this and think, can I do anything to that? It's 2 terms. It is a difference of squares problem the same way the one that we just did was, just like we did yesterday. This, we can go power divide by 3, copy sign, and power divide by 3. This can turn into this. And then quit looking at the original problem, look at this factor that we made, and continue the pattern we learned yesterday. First times itself, last times itself, and a different sign here, and just multiply them together and get an xy. Then we should think, is this factored completely or can we go again? These look like, oh, I forgot a plus there. This looks like maybe it could go again. And this looks like maybe it could go again. I forgot my plus there too. Always a plus at the end. These look like maybe they could go. I promise you, when you do a cube, that extra factor that we build from the first one, it will never go again. So don't waste any of your time thinking about that. It'll never happen. If you have a cube problem with just first powers of x and y, the extra second factor you make that's a trinomial, 3 terms, this trinomial will never factor. It can't, it won't, I promise. If we had done this, the cube pattern first though, you would have gotten a thing like this that could have refactored, and it would be really hard to do, and you don't want to do that. Okay, so if you get a problem like this that is a difference of squares and it's a cube, don't do the cube thing first. Save the cube thing for later. Save the cube thing for last. This one, again, first consideration is always, can we take out a GCF? And that answer is yes, we can take out a 2. If we take out a 2, we're left with a 1 minus a 16, and x to the 4th still sits there. So first move, take out a GCF, we're good. Second thing to consider is the number of terms and whether we factored completely, I guess. This has 2 terms. Generally speaking, in this homework, you're not going to do one quick hit. They're going to have these all set up to go and go and go some more. This is 2 terms, so it's either a difference of squares or it's a cube. It's not a cube because the power can't divide by 3. It's got to be a difference of squares. The 1 is on our square list from 1 times 1. 16 is on our square list from 4 times 4. And then the power on the difference of squares problem get cut, divided by 2, cut in half. And the only difference in these factors is that one gets a plus, one gets a minus. And now maybe we're done, maybe not. We've got to consider, did we factor this completely? Or if either of these pieces we saw on its own on a page somewhere, could we do something to it? And that answer is yes, one of these can break down. 2 is done. This is 2 terms. It's not a difference of squares because it's not subtracting anything. It's not a cube either because there's no ability to divide by 3. So this piece is done. Copy. This piece though is not done. This needs to get split into 2 new friends and not be part of the answer anymore, but replace it with 2 new friends. This is still a difference of squares. Difference because it's subtracting, so we're going to make our signs be different. Squares because 1 times 1 makes 1, and 2 times 2 makes 4, and the power can be divided by 2. And now we're done. These can't go more because we ran out of powers. If there's no powers, you can't factor. But if this had been, let's say, an 8, and we'd have gone down to 4, and then, if this was an 8, this would be an 8. Then we'd be down to 4s. Now we'd be down to 2s. Maybe we could go again, maybe not. It depends on whether the rest of the problem agrees. In this case, the 2 doesn't agree anyway. 2 is not a number that's on our chart, so that was pretty much in a dead end anyway. For this one, again, first step, look for a GCF. 7 goes into everything, so we're going to take 8 into everything. 8 to the 6 minus 1. Then be very suspicious. You're never, in this homework, you're never going to be done that quickly. Okay, we're going to think, can we factor this more? The answer is yes. 7 is going to continue on, and we're going to try to break this up into 2 things. It's 2 terms. A lot of things in this homework are 2 terms. 2 terms could be a difference of squares, which it is, because it's subtracting. It can be divided by 2, and 1's on our list. So I'll do that first. Even though it's also a cube problem, I already have said a couple times in this video, if it's a square and a cube problem, do the square system first. So powers divide by 3 to make doubles. 1 times 1 is making the 1, and go with different signs on that. And now these are both cube problems. Cube problems can have pluses or minuses. We don't care. We'll do them either way. The powers can divide by 3. And 1 is on our cube list. 1's turned into 1. I would encourage you to pause the video and do it yourself. Power divides by 3. Copy sign. 1 turns into 1. And I'm just focused on this right now. First times itself is a squared. Last times itself is a 1. Middle was a different sign. And a 1 times a. This became those. But this also has to become 2 other friends. The only difference with this one is going to be the signs. Plus became minus, so minus became plus. Otherwise, it's the same scheme again. And we want all of that because you have my guarantee that these will never refactor the ones that you made out of the cubes. One more problem as I stroll left, and it's the easiest one. Okay, so I didn't do anything with 3 terms because you already took a quiz with problems with 3 terms, like a million of them. So 3 term stuff is not new. We've been doing that. So there's nothing in this to refresh that. I did a lot of 2s and 3s because that was new. And the idea of going and going and going is kind of new. We've kind of done that, but not as much as today's homework will do. This is our first one with 4 or more terms. 4 or more terms, you could do this one by factoring by grouping, but I would recommend, if you ever can, just combine like terms. So if we look at this, there's an x squared that I always prefer it to go first. These are like terms, so I'm going to combine them to make that in the middle. I'm going to put the 12 at the end, and instead of 4 terms, now we have 3. And I think that's the easiest way to do this. Now we just unfoil it, by which I mean 2 sets of parentheses, x and x. We always look to this side first. If it's a plus, we go same as this. So plus, plus. And then we multiply to 12, but we try to add to 7. So 4 and 3 are the only numbers that do that. That's, I think, the easiest way to get that answer. If you wanted to do it by grouping, just to get a grouping reminder, you would take a 3 out of these first 2 to get x plus 4. You take an x out of the second 2 to get a 4 plus x. This is really the same as that, so we just copy that into the answer. And then 3 plus x, which is the same as this, could be the other factor. What I would ask you to do if you were here, but you're not, but I'll still ask you to do it, is take the problems on the little quiz and just try to do it for practice. And then we compare answers on stuff. So we could pause the video and then I'll read the answers I have for these for a second so you could do a self-check. If you have some that you can't do, I guess you could either email me and we could talk, or we could just talk in a room in person next time I see you or something. But you pause that while I find my answer key, and then we'll resume in a second with a series of answers on it. Okay, so after a brief delay, here's the answers to the problems. For 9, it's 3 terms, you just unfoil it. If you had x plus 2, I might give you half a point on that on the first day, but I'd really rather you write it x plus 2 squared. Every one of these quizzes will have a square on it, so look for something squared every time we do one of these quizzes. 10's a difference of squares, so we're going to go x plus 7, x minus 7. 11, all you can do is take out a GCF, so 10y comes out, x minus 1 left in parentheses. 12 is one where you have to guess check. If you have a number in the front and you can't do it, can't take out a GCF, I mean, you have to do a guess check system. So we'd go 3x versus x. The signs would need to be different because of the minus on the 4, and then you just guess until it like foils outright. Answer will be 3x minus 1 and x plus 4. 13, 4 times, so you have to factor by grouping. You would take a p off the first 2. You would take a negative q off the back 2. So one of the factors will be p minus q. The other factor, x plus y, because that would be left in both groups. 14, you could do factor by grouping, but I wouldn't. I'd combine the 4 and the 16 to get a minus 12 there, and then I would just unfoil it. X and x, signs are different. We're going to go x plus 6, x minus 2. 15 is a cube problem, so we're going to divide power by 3 to get an x, copy the plus, cube root to 1 to keep it a 1, so x plus 1 is the first factor. Then build the next factor from the first factor. It starts with x squared from x times x, then a minus to be different, then an x from 1 times x, and then a plus always, and then a 1 at the end. So 15 again has an x minus 1, it has an x squared minus an x plus a 1. 16, 2 terms, and it's a difference of squares. If you go x squared plus 4 and x squared minus 4, you're on a good path, but you're not done. If you stop there, I would mark that wrong, because the whole reason this question exists on the quiz is to go and go again. Every quiz will have at least one, maybe more questions where you can go and go again. The x squared plus 4 is a keeper because the plus dead ends that. It's not a difference of squares anymore because it has a plus. But the x squared minus 4 that you might have had as a starter part, You can't keep that forever because that's still a difference of squares. The x squared minus 4 has to break down to x plus 2 and x minus 2. So you get 3 factors. You get the x squared plus 4 you got stuck with from the beginning, but then you get an x plus 2 and an x minus 2 that you break down some more. 17, you want to take out a GCF of 3. If you didn't take out a GCF of 3, I'm just going to mark that wrong because that's the reason that exists, is to take out a GCF and then keep going. If you take out a 3, you get a problem that's going to unfoil really nicely. So you'll get a 3, and then in parentheses an x minus 4 and an x minus 1. So that's a little bit of general advice and answers on those. If you missed the answers, just rewind. If you need a little bit more specific advice, email me and we can figure out a way to give you specific advice, or just visit me in the morning next time you're in the building, and we'll take this quiz next time that we're all in the building together. So that's it.